can modify slightly and make tomorrow kind of our flex work day. We want to wrap up lesson 8.2.3 and make sure that you're really comfortable with all that negative exponent work. And then we want to, at some point, go ahead and get into 8.2.4. So that would either be today or tomorrow. And then whatever day is not the get into 8.2.4, we will use as flex / catch up / works inside kind of stacked homeworks, bleeding over multiple days like every day this week. So as we talked about yesterday, we finished 8.2.2, and then the 8.2.3 assignment was fairly large. That's still your homework tonight. That's your primary. But then we need to do 8.2.4 at some point. So we're like, it's up to you guys. So would you rather, I don't know what you're doing in your other classes, would you rather use today as wrap 8.2.3 and just like work then? Or go ahead, dive into 8.2.4 for a few problems, and then you're ready to do like all of the next homeworks? Like really what it comes down to is if any of you are done with 8.2.3's homework, you probably want to go ahead and see the 8.2.4 lesson. Which really 8.2.4 is just application. It's using scientific notation in real situations. So it's not like new knowledge, it's application. So here's my suggestion. Veto me because you're all just staring at me. My advice would be, because today's Thursday and tomorrow's Friday, today we keep rolling. We wrap up 8.2.3, which really is just if there's questions, let's talk about those questions. Do 8.2.4 for 20 or 30 minutes, and then use like a few, like the end of class today to do homework, but then all of tomorrow would pretty much just be flex.
Okay, I'm good with that.
And I mean, it's a Friday, it's Friday creative option, it's weird, that would make more sense to me, but I have stacked up your practice this week, so I want to give you a day to kind of catch up, and we've just merged lessons together. So, Octavio?
It's not Friday.
Tomorrow's Friday. So what I'm saying is it will be Friday with Friday creative option, the weird schedule, the weird timing. It makes sense for tomorrow to be kind of a flexible day. All right, so our work with negative exponents, we yesterday got down to here, talking about how this defines and kind of solidifies what we're doing. So if we extend that to 76 and look at, I'm going to guess we pronounce that knock. I really don't know. We could try to have Google say it for us. But so he's got 2 to the 5th is 32, 2 to the 4th is 16. 2's are mildly important, like powers of 2, because binary, or situations that have like a yes or a no or a heads or a tails sort of thing, those probabilities you can talk about using powers of 2. So learning some of those powers of 2 might be convenient. 2 squared is 4, then 8, then 16, then 32, and it keeps going. So then, 2 to the negative first, he says, based off what we saw yesterday, apparently I have to reset my smart board. Based off what we saw yesterday, 2 to the negative first, he says, is 1 over 2. Do we agree? Yeah, why? What do negative powers tell us to do? Who can refresh that memory, George?
Instead of moving the decimal to the right.
That's scientific notation.
No.
We're talking about not scientific notation yet.
Oh.
You're right if we're talking
Okay.
about scientific notation.
It's doing 2 divided by 1 divided by
Braylon.
How many times you have to divide?
It's multiple divisions. So 2 to the negative first just means divide it once, but 2 to the negative second would be divide twice, so it's 1 over, yeah, I gotta restart smarting. Go ahead and try to write it on your paper if you think you know what it would become. I don't know why Smart Ink is waging a, no, like, not a war necessarily, they're just like, you know, refusing to work. It's like a strike. A smartboard went on strike this morning. So this becomes 1 over 2 times 2, or 1 divided by 2 times 2 is another way we can write it, because repeated division. Or you could write this as 1 divided by 2, then that divided by 2, which, but really the easiest way to write it is 1 over 2 squared. Because when we take the numerator base to the denominator, that uses up that negative in the power. So who plays video games? Yeah, most of us. I don't actually. My hand should be down.
What?
But you know, like when you get something like in what's the game with the backpack? It's like infinitely large.
Pokemon?
Okay, like it's
Any
not.
game.
I don't think it's half Fallout. Right, so
Fallout.
Fallout. You walk around collecting stuff, right?
Actually,
When you use it, you either lose one of those items if you have multiple items, or it just disappears out of your pack, right? And a lot of games do this. This is what we're doing here. We have 2 with a power with a negative and a 2. We've used up the negative. Now let's use up the 2. Like the power of 2, it becomes 1/4. So first thing we do in 2 to the negative 3, use up your negative. So that makes it 1 over 2 to the 3. That uses up your negative. Whatever sound effect you give it. Then, I'm coming to you in just a second. What's 2 cubed?
8.
So we get 1, 8. Do it one thing at a time, please, until you get comfortable. Okay? Questions on those? So can anyone justify, I'm going to ask this, then I'm going to come to Quinn and see what he's talking about. Can anyone justify why 10 to the 0 and 2 to the 0 would be the same thing? Quinn, what do you think?
Because they're 0.
What do you mean?
If you had 10 times, because it's to the power, so if you had 10 and then 0, it wouldn't mean anything because it would be 10, 0, or no, 10, 0 times.
So is it 0 or is it 1?
0.
Other opinions? Mallory? Mallory thinks it's 1. So if I look here at 2 to the negative, where'd this 1 come from?
The negative.
Aren't all of it, like, when I say good morning to Quinn, I don't say good morning 1 Quinn. There is 1 of him, but I just say good morning Quinn. There's always a 1 involved in our situation, right? I have 1 2 to the negative 2nd power. So this 2 going to the denominator, the 1 still stays in the numerator. It still exists. That's how it becomes a fraction. So there's also 1 times 2 to the 3rd up there. And if we have 2 to the 0, it's still 1 times 2 to the 0. George?
Okay, I just need to relate this to science. Because we're doing the same thing about trying to get, well, this is just kind of the same, but when we're trying to make formulas,
Yeah.
like balanced formulas
Yeah.
for science, there's always a 1 in front when instead of having like 2 carbons, there's always a 1 carbon too. So when you're balancing and there's already something there, you just put a 1 instead
There's
of
always a
yeah.
1 there. Yep, very good connection. So, what would this mean if it was 2 to the 3rd? Positive. Multiply by 2 3 times, right?
Yeah.
Times 2 times 2 times 2. To the negative 3rd, it would be divide by 2. Divide by 2, divide by 2. So 2 to the 0 means don't do anything with the 2.
So it's just 1.
It's just 1. Any value raised to 0 is 1. I don't care if we know what the value is or not. X to the 0 is 1. 7 to the 0 is 1. 8 billion, 4 trillion, to the 0 is 1. Any value to the 0 power, you might want to write this down. I see some people doing it. But any value raised to the 0 power says, well, there's a 1 out in front of that. And the 0 says don't do anything. So it stays 1. Now, the most common mistake is thinking that that makes 0. No. Now, the other way to think about a 0 power. Let's see if this works today. Yay! Maybe my smart board has decided to cooperate now.
Yeah.
What if we had Like, I'm going to look at 78, but change it just a little bit. What if we had that? 5 to the second times 5 to the negative 2.
Well,
Hold on. What's the negative tell me to do? Put that value in the denominator, right? So this becomes 5 to the second over 5 to the second, which is 5 times 5, 5 times 5. Right? 1. But guys, if I come back here and I apply that subtraction rule, oh, give me calligraphy. Come on, let me be fancy. If I apply my subtraction rule, I get 5 to the 0. And we know that anytime there's a value over itself, it's 1. So that's another reason to defend that any power to the, or any value to the power of 0 is 1. Always in play. Preguntas.
Always.
Are you kidding?
Nope.
Hey guys, at 10:40 we have a fire drill.
Dang it.
So on your way to your next class, you guys know I'm just straight up with you guys. On your way to your next class, if you are afraid of being outside for 2 minutes in like 30-ish degree weather probably, grab your jacket real fast. No, they'll make it fast. We just have to fit it. Guess what today is? The last day of February. So if you want the honest truth, there was so much going on with Phoenix, we kind of lost track of February, and all of a sudden we were like, oh, we need a February fire drill. So, because you have to do one every month. It's state law. Yep. Sorry, you go to public school. Sorry. All right, hold up. Are there any remaining questions about negative powers, positive powers, or 0 powers? Otherwise, we'll go practice some of the scientific notation in the next lesson. Like, these next couple problems are what we're essentially about to do.
I'm assuming, like, just, can you have the fraction power?
Mm-hmm.
You can.
Do you want to know what it does?
Yeah. Now I do. I was thinking about it. Wait, wouldn't it be
can a power of a power have a
I don't know if you all are ready for this. All right, zip your lips for a moment. I just want you thinking.
that means X. That means X.
So x squared. X to the negative 2.
1 over
X to the 1. I'm going to skip this for a moment. So FF, we says really F squared, right? And if Z equals 9, and Z is some number, right, Marley? times itself, what would f be?
4.5.
Ooh, you're adding
Is it 3, right?
Oh,
3.
yeah, 3.
Oh,
I knew that.
So, wait, but if I made this z to the negative, that's 1 over z, that becomes 1 over 9. That's not what I want.
What?
Okay, that's cool.
To take a value to a half power, you are saying that there is some other value. Here we're going to say f. These are equal. That when, now you don't need to know this yet, but I like over teaching. Let's relate this actually. So Quinn, you for a moment said 4.5.
Yeah.
Right? Because if we had a situation of 2 times x equal to 9, x is 4.5, why? What, why? Why is it 4.5?
9 divided by 2 equals 4.5.
Because.
Oh, I thought it was B over C.
Sorry, I shouldn't use that in math. So, x is 4.5 because I need 2 of the same thing to add and make 9. But we're talking about addition when really I've written multiplication. So now when I step up and I write a power, that's really talking about multiplication, right? This operation really represents repeated that operation. So we're looking for some value that when multiplied by itself will equal the thing we have. So when f equals 3, f squared equals 9, which really, if you want to abbreviate everything I'm trying to explain to you, just to the what does it actually do, Mr. Hudson, stop talking. It's the square root. A half power is a square root.
So I see that.
Now, a negative half power, I love that you continue to ask, but wait, what if?
That was a negative half power that you wrote.
Yeah, you wrote a
Oh, sorry. I didn't mean to put the negative there. My brain is getting all confused. Sorry, negative half power, I will show you. My brain's getting all mixed up. Z to the half.
Is it negative square root?
Nope. Remember, what does the half power do?
Half power makes it a fraction. Oh, no.
Apply the negative and apply the half.
Wait, what if we do like 1/4 or like 1 something or something?
You tell me. If I need to change variables, h to the 1/3. So if we formally write the square root symbol, there's a bitty 2 in there. H to the 1/3 is the cube root of h, which means there's some number,
So if you put a 4 in there,
which means there's some number that the number times that same number times that same number equals h. So if you had 8 to the 1/3, a number times itself makes 8. That's the cube root of 8. The number we're looking for is 2. Because 2 times itself is 8.
I mean, the 1/4 is going to be itself times itself
Times itself one more time. Yeah, 4 of them. Now, here's the problem. People will approach something like this and they'll say, yeah, okay, so like 9 divided by, and they start thinking that way. Ask yourself, what times itself makes 9? So if somebody told you, like, z squared, and then I should actually use a different variable. Say we said b squared is 10. If they then asked you what's b, well, b is some number that when multiplied by itself has to equal 10. Here, b's a really, really, really gross number because it doesn't work well. But if b squared was instead of 10, because think of a number times itself that makes 10 that doesn't really like, it's going to be 3 point something. If b squared was 16, what times itself can make 16? 4. So you don't need to know that. But you asked the question, so I can't resist. Yeah.
I wanted to point out from earlier when you were referencing. I wanted to point out from earlier about Fallout. They don't really. It doesn't use bags. It uses Pip-Boys. But even then, it doesn't make sense because how can you cram guns and armor into a little can?
Yeah. Don't expect me to ever know the real details of video games.
Okay.
All right. So you are going to have an amazing opportunity. Well, not really, probably, but the opportunity will be there, but I doubt. Okay, maybe if you become famous or somehow rich or win the lottery. What? It's hard to become rich unless you're like a bad guy. You may actually, and this is already happening. They're already selling tickets. You may actually, in your life, have the opportunity to go and visit Mars.
Really?
They're selling tickets.
They are selling now. What they're selling now are tickets for the first commercial space travel, not to get to Mars, but they will take you in essentially a spaceship up out of our atmosphere. So you are technically in space, and then they come back. That's what they're selling right now. So right now, there's commercial travel taking people just like a plane to Florida, taking people into space and then coming back. So, show them what? From way up there, it just looks like a circle.
Yeah.
So, we start talking a lot about distances in space because here's the issue. Florida might feel far when I'm in a car, but it feels a lot closer when I'm in a plane, right?
Yeah.
Mars is far.
Yeah.
There's no like arguing that. It's very far. So the problem right now is like you'll age so much on the way to Mars, like it's the travel there would be really tricky. But all of that to say, we care about distances in space because we use them to calculate things. Guys, think about it. We landed with perfection a rover, like a remote control car, like the size of a car, on a planet that's moving, that's like thousands and thousands of miles away. I forget the exact distance, but like that's pretty sweet. And they needed to know some pretty darn good numbers. So when we start looking at Alpha Centauri, which is, if you haven't heard of it, it's one of our popular like stars to talk about. Alpha Centauri is 4.13 times 10 to the 16th meters, or the radius of a hydrogen atom comparatively is 5.29 times 10 to the negative 11 meters. So here's a really crazy question that doesn't matter but is fun to solve. If we wanted to make the distance between us and Alpha Centauri full of hydrogen atoms, how many hydrogen atoms would it take to get there? Stop. If we had to go 100 feet and we could take 5-foot steps, how would we solve how many steps?
By dividing it by 5.
By dividing our distance by the amount for each step. So to calculate the answer to this problem, we're going to take our entire distance, this is a whole lot easier than what you guys realize, and divide it by the size of a hydrogen atom. So please write on your paper 4.13 times 10 to the 16th all over, obviously this has been rounded to quite an extent, all over 5.29 times 10 to the negative 11. Break up your pieces. Breaking up is hard to do. Someone with a calculator, please tell me what 4.13 divided by 5.29 comes out to be. And it's going to be less than 1. It's going to be less than 1.
Marty's doing it.
0.780.
Yes, 0.78.
What comes after the 0?
7.
Okay, let's at least do that many.
What comes after that?
Now, somebody without a calculator, what's 16? Oh, wait, what did we say the rule is here with powers?
Just subtract.
Subtract, right? So when we're dividing, we subtract. What's 16 minus negative 11?
5.
Yeah, right, because minus a negative is plus.
Yeah.
27.
Now, this is broken. It's not in scientific notation. If we go to fix it and we move the decimal to the right, that takes away one of these, because that's what the 27 tells me, right? Move to the right. So this becomes 7.807 times 10 to the 4. Who said 14? Don't actually raise your hand, but guys, like, wake up and pay attention to what we're doing, Gwendolyn.
26.
This becomes 26. You're lucky I didn't walk back there and give you the like, I don't even know what treatment to call it, but if somebody's got their head on their desk, my favorite thing to do is just go lift their desk and drop it. How to teach you to put your head down in my class. You realize how much effort us teachers put into making sure that you have a decent experience here, and for you to come in, I'm not talking to you, I'm talking to everyone, and not even be able to give us 40 minutes of your head lifted off a object. Like, I mean, look at that. Like, yeah, man, quit getting horizontal. I'm going to take that second chair. I'm going to take all chairs away from you and just make you stand. So, if we're going to make that distance in hydrogen atoms. Now, hold on. Let's actually try to quantify this. How many digits fit into the name of a place such as thousands, millions, billions? Like, how many zeros? 3, right? Sets of 3.
Yeah.
So the first set of 3 just gets us to thousands, right?
Yeah.
How many sets of 3 are there in 26? If we make it a multiple, 8, right? So if we do 24, would give us 8 sets.
That'd be an octillion.
So 1,000, million, billion, trillion, quadrillion, quintillion. This is where it's weird. Quintillion actually uses 6 sets, right? What's 6? No, that's 9.
Septillion.
That's 7.
Sextillion.
Or sorry.
Pentillion, right?
Million, billion, trillion, quadrillion, quintillion. I forget. But then, okay, so skip it. Septillion, like octillion. Wait, I think. But then we still have 2 more. So it's 780 I think. We might have miscounted. It might be nonillion hydrogen atoms.
What?
It's that many but now we can easily we don't even have to write it out. If I count right and know what that
It's
million,
not
billion,
billion,
trillion,
I think.
yeah, we might need to look it up. So this is why we do that. Now what they would really do is probably quantify this into how far can a spaceship travel in a day, and we do math with that sort of stuff. But if we want to do that same sort of thing, I'm going to come to you in just a second, talking about whales.
What?
Because, why not talk about whales? So, check it. A typical dwarf sperm whale, the planet's smallest whale, which sounds funny to say, weighs about 3 times 10 to the second pounds. That's not very much. That's 3 times 10 times 10. A blue whale, which is the largest whale, weighs 4.5 times 10 to the fifth pounds. How many dwarf whales would you need to equal a blue whale? How many dwarf whales would you need to equal a blue whale? Hey, here's a point that's worth making. Depending on what calculator you're using, it'll pop up with E and then a number. E means times 10 to the. Why they use that is exponent. They're telling you the exponent of 10 is. So if you got an answer of like 4.2 E 12, that's 4.2 times 10 to the 12th power. Okay, it's worth noting that in case you didn't know that.
You would need. You want me to? Because I got the answer.
Yeah, you do not need a calculator for this, guys.
Literally everyone gets a calculator. The hardest part of this problem is trying to figure out which button to use to get.
You don't need a calculator. Hey friends, in the advanced math class, what's 4.5 divided by 3? 1.5, right? Come on, you don't need a calculator for that. Look, I'm fine. Hear me when I say this. I'm fine with you using calculators. But please, use your brain. If your brain can do it, do it. If not, get a calculator. But if you can do it, just do it. All right, 10 to the 5th, 10 to the 2nd, we end up with. So it would take 1, 2, 3 from my power. It would take 1,500 dwarf whales to equal the weight of a blue whale. Now the question, because you guys have been doing this in science, is would they be the same volume? Right? Are the whales going to have the same density as each other? I highly doubt it. So like I imagine like a swarm of 1,500 dwarf whales all swimming together. My question is like, is that swarm going to be bigger than the blue whale or smaller? And that comes down to density, right? Which you're now starting to understand through science. Like which whale would be more dense? And guys, that's honestly, if you've ever heard the expression, or really it's a fact, that muscle weighs more than fat. Like when people talk about numbers on a scale, it's really like ambiguous. Your scale number isn't really that good of an indicator, because if I go to the gym and I pump a bunch of iron and I make muscles, a cubic centimeter of muscle will weigh more than a cubic centimeter of fat. It's density. So that, like, yeah, just be careful when we start talking about weights and masses and things like that. Try this real quick. Mr. Cabilo will be happy about this. There are about 1.8 times 10 to the 21st molecules in 1 gram of table sugar. If a baker uses 8 times 10 to the second grams in his recipe, how many molecules of sugar did he actually use? Now be careful with what math are we doing here. That's how much is in 1 gram. And then we know how many grams they use. See some people not doing math. Disappointing.
I'm just trying to see what to do.
That's 1 gram. That's how many grams they use.
So in a way, guys, this is like your density study. And I've helped a few of you with that density mastery. Your density gives you milliliters per, grams per 1 milliliter. Instead here, though, they're giving you molecules per 1 gram. And then they tell you how many grams we use, which bakers get real precise. I've been watching more and more baking shows and people like weighing stuff and like making things perfect. And no, I like the kids baking shows and things like that. Yeah, yeah, kids baking shows are great. If you haven't figured this out, I like kids. Like it's fun. I miss being kids. It's awesome. What math do I do, Olivia? Do I add, subtract, multiply, divide? You got a guess? Not here, actually. Who else has ideas? Not George. Love you, George, but I can't have you run the class. Marin, you look deep in thought. What's your idea? Mr. Cabilo, you might be able to help here. This somewhat relates to density, and we were just talking about density, how it's like grams per 1 milliliter, and then we give them an amount of milliliters. Guys, this is the same thing. Mr. Cabilo, if I give you molecules in 1 gram, and then an amount of grams, what operation do you think I need to use to solve the amount of molecules? Who thinks Mr. Cabilo is right that we should multiply?
Well, he's older than me, so I probably should.
With a little dance. Guys, we know how many are in 1 gram, and we know the amount of grams we have. Each of these has that many. So we take our 1.8 times 10 to the 21st. Please write this out because this is something we haven't practiced really yet. Times 8 times 10 to the second. And again, break it apart. We're doing 8th grade math. Hi, welcome to Compressed 7-8. We're in that 8 part of the year. I hope you take that as humorous, but it's funny you just said that because we've been doing 8th grade math for 3 chapters. What is 8 times 1.8? 14 point what? Sorry. 14.4. 10 to the 21st times 10 to the second? 10 to the 23rd, be careful right now. But then, I think you're ahead of us, Connor. This is broken. We have to fix it. What do I have to do to fix it? We'll bounce back to Braylon because we just talked to Olivia.
Okay, you have to make, there shouldn't be anything in the tens place.
Okay, there shouldn't be anything in the tens place, so I move my decimal there. Becomes 1.44, but now times 10 to the 24th. Be careful. Guys, every year, this is where students struggle, and I'm not like going to try to give you some trick of whatever, like, the positive power tells me I need to move right. I just gave it another space. It's gonna have to move right to get back where it should go. So I have to increase that power because I just added another step it has to take. If I, like in the last problem we did, take away a step that it has to take, then I subtract from that. If it's negative, though, it essentially works the other way around, right? Because the negative power tells you to go left. If I move my decimal right, I'm adding another left shift. So this comes down to practice, guys. Your new answer keys are posted in Schoology. Please. Like, seriously. This stuff, check your answers. It's easy to get yourself in a habit of thinking you're doing it right when you're not. And then you'll learn the rule backwards. Please check your work as you go. I forget what it was, but luckily somebody reminded me yesterday to post that stuff. So I got it up on Schoology. Yeah, thank you, Olivia. Got it up on Schoology now, your answer key, and there's a new discussion board. So if anyone wants to get on the discussion board, meet up over spring break, whatever. If you're behind, like get help from people. If you're way behind and someone's really going to help you out and like tutor you, please like give them some sort of appreciation, like some Girl Scout cookies or something. Yeah, if somebody like takes their time outside of school, like that's worth something. All right, we're done in this class. If you need your jacket for the fire drill, get it on the way to your next class. To what? in the yeah. Hey, Olivia found out our space travel ticket. If you just want to go up into space and back, is only $250,000. It's only $250,000.
Only.
Well, most planes can't deal with the pressure because the pressure gets so strong up there. Like you have to have a specifically designed craft to safely do it. Now the military does have some planes that go really, really high, and then they do those like parabolic arcs, but that still doesn't even get into space. They mess with gravity because the angles that they take. Yeah, interesting. We'd have to look it up for me to be sure, but I mean, you probably know more than I do about that right now.